So how would you do number 23? I get 24.
23 is the same thing, it just uses radians instead of degrees. So honestly, the easiest thing to do there would be to use the square, to convert 2 pi over 3 to degrees. And then figure out what that actually would be.
So you can convert it to degrees.
You could convert it to degrees to figure out this, what I have up on the screen, and then convert the degrees back to radians. Or just understand that you could subtract or add it to pi over 2, pi, or 3 pi over 2, depending on where it falls. Most people would convert it to degrees. Okay, y'all wanted to get to which number?
25 or 26?
All right, let's get to 20. Who?
Wait, how do we do 25 or 26?
You told me yesterday we didn't need to know how to do that.
I did say that. You're right.
I feel like I know how to do it, but I'm just having.
All you're going to end up doing on that one is my recommendation: just use the X and Y chart.
But we don't have to do it, right?
25. 6.
What chance either?
Chapter 6.
I don't know what chance.
I don't even have the answer.
He sounds girly.
Okay.
Does he really?
Yeah, what I would do on number 25, 26. 25 and 26 was under the chapter, the lesson of inverse, direct, and jointed relationships. And it would just, you basically just used an X and Y chart in order to do that. I don't think I'll put any of those on there, but if I do, and I may, you just make an X and Y chart. Just do an X and Y chart. That's it.
So then your F of X would be Y.
Yeah, F of X is Y. That's right. So 26 is like saying Y equals the square root of X minus 2. I'm sorry, the square root of X minus 6 all over 2. Yep.
X and Y chart.
X and Y chart. Just go with it and you're good to go.
Oh, so we just got through all the hard stuff.
Well, I don't know. Some people, y'all may think the graphing on the polar coordinates is hard still.
Oh, I like that. I really
29.
Yeah,
Well, that's
I
good.
really like it.
Yeah, me too.
It's like, you just like,
I just want to graph cardioids and limitoids and
Every
limits.
time.
I know.
That's an exact answer.
That's what I like.
There's an exact answer for everything.
Yeah.
There's an exact answer for everything.
We just did one where it had 4 answers.
But it was an exact 4 answers. I mean, they're all exact.
Exact 4 answers.
Exactly. Okay. So y'all requested 29. So the first thing, it's a polar coordinate system.
It's a limison.
So you need to think and understand what it is. It's a limison.
It's a limit state with the loop. I mean, a limit
No, it's a
limit.
lemon song.
All right, limison with a loop. So it's going to follow the format R equals A plus B cosine of theta, right?
Yeah.
All right. So let's see here. Let me go back to my page.
Oh.
Graph.
All right. Also, A here is 2, and the absolute value of 2 is less than the absolute value of B. So that indicates that this is a limison.
I love these
With
so
the
much.
loop.
I should do it that way. Limison
Squiggly. Oh, wow. That hurts. Thank you.
with a loop. Okay. So this one conveniently matches the book exactly in terms of its format. So you guys have this written down, hopefully, on your formula cards. Looks something like this, right? It has an inner loop. Keeps going around like this. That's the picture that we're going to reference.
Wow.
And let me
That
reduce
was
this down.
really, really bad.
Make sure you have all your points. What's the y-intercept up here?
0 and pi over 2.
A and pi over 2.
Oh man.
This point right
Oh,
here
you read
is
already. It is an
A plus B
Yep.
and 0. This point right here is the origin, so I don't even need to mess with it. This point right here, though, is what?
A minus
pi.
B.
Oh, they did that. Pi.
Technically, it's the absolute value.
It is the absolute value. The absolute value will take effect when it's without a loop.
So you need the absolute value part.
You will need that,
Okay,
yes.
then I got it's going to turn out to be
Okay,
-1.
and then the bottom point here is going to be
That's the only question I
A
have.
and 3 pi over 2. So you guys good with this?
Yeah, man.
Y'all should have that all written down on the formula card, okay? Now I just plug in my numbers. So I'm gonna actually graph it now. You can go ahead and sketch it exactly like it is, but I'm gonna go ahead and mark my coordinates here. According to this, I have A minus B, which would give me, the absolute value of that would give me what?
One.
1, because a minus b would be the absolute value of 2 minus 3, which is the absolute value negative 1, which is equal to 1. So my inner loop starts at 0, and then it crosses at 1. What's the y-intercepts? Well, it'd be a and pi over 2, right? And a and 3 pi over 2. But what's a equal to? 2. So I need to go up 2 tick marks and put a dot, go down 2 tick marks and put a dot. And then I need to figure out where this all ends up down there at the very tip. It's a plus b, which would be 3 plus 2, which is 5. So 1, 2, 3, 4, 5, put a dot. There you go, now you're ready to graph this.
Woo, I did it.
First thing you want to graph is the inner loop,
Woo, I did it.
and then keep going around.
It's a heart.
Hi.
You-
Let's do number 30.
Why?
Because we want to.
Why?
I had to do
R
mine
equals
myself.
6.
Something like that.
Sine.
Can we have all the tests full of this? I love
Data.
those
So this
so
one's
much.
one of those
Wow,
that's
y'all
going
love
to be
these.
This is like a
sideways.
brownie cake.
Okay? Can you guys go look at this? Any questions? Yeah, we'll give you 30 real fast.
Dirty 30.
Oh,
30?
I like these. so
It's
much.
where n is even.
Okay, so,
Petals.
So r is equal to
So-
6 sine
But it's sine.
of 2 theta.
We can do it.
Well, what is, you already know what sine's gonna do.
It's just going to do
It's on the
sideways. It's going to be on the,
It's
at
gonna
the other
shift
axis.
around how
90
far?
divided by 2.
On the
45 degrees.
90
90.
divided by 2, yes.
So literally just graph it sideways. Turn your paper sideways and graph it.
Sort of, let's, yes,
That's only when it's signed, correct?
correct.
Okay,
If it's
thank you.
cosine, it'll be on an axis.
Okay.
I did not look at the
Most,
sign
more
part.
than likely, yes. So we gotta look at
Oh, it's
this,
those-
we have,
petals.
this fits r equals a sine of n theta. So n is equal to 2. So when n is equal to 2, that's even. What does that mean?
How is it by 2?
It's 2n will tell us how many petals we have, which would give us 4. So there's 4 petals to this.
Oh, no.
All right. Normally, 4 petals would look like, this, something like this.
But it's sine, so it's just a separate.
That's right.
It's a 4-leaf clover.
It's a 4-leaf clover, but I'm just putting these points for us to reference, okay, real fast. So if we pay attention, we'll get this really fast. This point up here is gonna be, the textbook uses negative, it really isn't gonna make a difference. A and pi over 2, this is A and pi, this is A and 3 pi over 2. So you guys are right, this whole thing is basically going to shift around 45 because it's a positive sign. If it was a negative sign by chance, it would shift down, but again, it's gonna look the same because even though it shifts down, it ends up looking the same. So I need to draw this out. It's gonna start here, and it's gonna go into 45, 45.
Strangely confident for this test.
I'm gonna fall asleep at service last one.
Oh, this
Don't
part.
miss. No, you won't, they're good services.
A equals 6, so it's like, yeah.
So make sure you do include your coordinates here, guys. What is A here?
6.
A is 6. And this is now gonna be what?
Pi over 2.
Pi over 4.
That's what I'm doing.
Because what is the angle that this is at?
45.
It's a 45-degree angle. So everything is gonna shift 45 degrees, which is equivalent to pi over 4. So what's this point over here gonna be?
6 and pi, 3 pi over 2.
It's pi over 2, which would be right here, plus this distance, which is pi over 4. So pi over 2 plus pi over 4.
Pi over 6.
Calculators would come into play here.
What's that?
It's 3 pi over 4. It's 3 pi over 4 is what I got.
Pi over 6, guys.
I don't know.
Well, because it'd be 2 over 4, and 3 4 pi. How about the one down here? Let's just finish this real fast so everybody can have it. 6. And again, all the way from here to here is how far in radians? Pi. So I need to go plus pi over 4 more to get to this line right here. So it'd be pi plus pi over 4, which is 1 1/4 pi, which is 5/4 pi.
Yeah, they're.
And then from this one, all the way around to this piece is how far?
3 pi over 2.
3 pi over 2 is right, but I need to go 45 more.
Plus 4.
So 3 pi over 2 plus pi over 4. Find your common denominator, it'd be 4, so that's 6, 7,
7 pi
7
over
pi
4.
over 4. So this point right here is 6, 7 pi over 4.
Yay!
There you go.
I think the reason why we like to do it is because remember that day instead of how we all did it together?
Yeah, yes.
I really did that.
But I love
Oh, yeah.
I love these figures.
All right.
So can we do that
There
for
you
a
go.
test tomorrow?
Okay, bye,
I'm
Bailey.
gonna be on there.
Say bye to Bailey.
Bye,
Bye, Bailey.